Assalamu alaikum. This is chemistry 12th, and our today's topic is haloarenes, or we also call them as aryl halides. Now, as far as these haloarenes are concerned, these are the halogen derivatives of benzene, which are or aromatic hydrocarbons, which are obtained by the replacement of one or more hydrogen atoms from the benzene ring by halogen atoms. Now, as far as these monohalogen derivatives of this aromatic hydrocarbons or benzene are concerned, they are named. These can be named by adding the suffix uh, halo, that is chloro, bromo, iodo before the parent before the name of the parent hydrocarbon. For example, we have got chlorobenzene, we have got bromobenzene, we have got iodobenzene. Now, as far as the dihalogen derivatives of these aromatic hydrocarbons or and this benzene are uh, uh, concerned. Now, while writing the names of these dihalogen derivatives of this benzene, we use the relative position of the substituents. The relative, this is when there are two halogen atoms present in the ring, that is dihalogen derivatives. Now, in writing the names of these dihalogen derivatives, we the relative position of the substituents at 1 and 2, 1 and 2, that is indicated by ortho, and if the position of these the two substituents is at 1 and 3, then it is indicated by using this meta. Then similarly the position at 1 and 4, that is indicated by para. Now see here, this is chlorobenzene. Now in this case we see that we have got a monohalogen, this is monohalogen derivative. Then we have got this uh, benzyl, this chloride. This is in this case we see that we have got a side chain, that is CH2, to which is attached this chlorine atom. Now then you have got this is benzyl chloride. Similarly we have got toluene. Similarly we have got this is one this is at position number 2, we have got chlorine atom over here. This is 2-chlorotoluene, or we can also call it as O-chlorotoluene. Then we have got when the chlorine is at position number 3rd, then we call it as metachlorotoluene, or we can also call it as 3-chloro, since it is at position number 3 starting from this methyl group, that is 1, 2 and 3. Similarly, in case when this halogen atom is at position 4, then this is this we call as this called p-chloro or parachlorotoluene. Now this is how the these aryl halides or haloarenes are named. Now, as far as their these properties, these preparation is concerned, we have got various methods for the synthesis of these aromatic halides or haloarenes. One of the method, that is this by direct halogenation of the aromatic ring. Now, in this case, the halogenation of the aromatic ring is carried. It is carried out in presence of some halogen carrier. We have got this ferric chloride. We have got ferric. This is bromide. Then we have got aluminum chloride at a temperature of 310 to 320 Kelvin. Now this reaction is carried out in dark. It is not carried out in light. Now, as far as this reaction, these halogen carriers are concerned, we have got ferric chloride, we have got ferric bromide. We can use any of these. These are called as halogen carriers, and they are also called as the Lewis acids. So what is the purpose of using this halogen carriers? Say for instance ferric chloride. This is used to generate generate the electrophile. Since this is an electrophilic substitution reaction, this ferric chloride, which is a Lewis acid, it is used to generate electrophile, that is a chloronium ion, which then attacks the aromatic ring, giving rise to the formation of arenium ion, which gets then stabilized through this resonance. Now here you can see that this chlorine atom, this takes out this hydrogen atom, it gets substituted uh, to give rise to the formation of chlorobenzene and HCl. Now I have told you that this the purpose of adding uh, this halogen carrier is to generate the electrophile, that is chloronium ion. Now this is an electrophilic substitution reaction. Now then, if we have to prepare a bromobenzene, in that case we will have to use, accordingly we will use this is ferric bromide, ferric bromide, and the resulting halide will be bromobenzene. Now this is one of the method used for the synthesis of these haloarenes. Then another method which we have got, that is called from diazonium salts. So this is a well-known reaction. It is known as Sandmeyer's reaction. This is the best method for the synthesis of these aryl halides. Now as far as this reaction is concerned, what we do in this reaction, a freshly prepared diazonium salt, it is decomposed by cuprous chloride, which is dissolved in the corresponding halogen acid. Now, or if we have to prepare this bromobenzene, then we can use cuprous bromide in the corresponding halogen acid, that is HBr. Now, as far as this reaction is concerned, this freshly prepared diazonium salt is, first of all, it is prepared by treating sodium nitrite with HCl, and that gives rise to the formation of this nitrous acid. Now this nitrous acid, then it is treated with aniline. Nitrous acid, upon treatment with aniline, this is the reaction is this is ice cooled solution of this aniline is taken out, and it is made to react with this nitrous acid. Now at a very low temperature of 273 to 278 Kelvin, to give rise to the formation of diazonium salt, that is benzene diazonium chloride plus water. Now this diazonium salt is then it is then decomposed by using it is then decomposed in this Sandmeyer's reaction. Now the above reaction, that is the generation of this diazonium salt, this is called as diazotization. And in diazotization, I have told you that these aromatic amine and aromatic amine, that is aniline, it is treated with nitrous acid at a very low temperature to give rise to the formation of this diazonium salt. This is known as diazotization reaction. And in this once this diazonium salt is prepared, it is then made to react with this cuprous chloride using the corresponding halogen acid, that is HCl, to give rise to the formation of this chlorobenzene nitrogen plus HCl. So this is called as Sandmeyer's reaction. Similarly, if we have to prepare this bromobenzene, in that case we use this diazonium salt, that is benzene diazonium chloride. It is made to react with cuprous bromide, and the corresponding this halogen acid, that is HBr, is used. Now the resulting this product is this bromobenzene plus nitrogen plus HCl. Now in this reaction, this is known as Sandmeyer's reaction, and I have told you what we do in Sandmeyer's reaction. Benzene diazonium chloride, it is decomposed by using this cuprous chloride and corresponding this halogen acid. Now in this reaction, we can't prepare this iodobenzene cannot be prepared by this method, because because a hydrogen iodide that is formed formed in above reaction. In the first reaction, that is this direct halogenation. We can't prepare this iodobenzene because the hydrogen iodide that is formed in the above reaction, that is highly reducing, it is a reducing agent, and it can reduce this iodo this benzene back to benzene. Now as far as this Sandmeyer's reaction is concerned, in this we see here decomposition of this diazonium salt takes place by using cuprous chloride and the corresponding halogen acid. Then there is a modification over this reaction, and the modification is that instead of cuprous chloride we can use copper powder and the corresponding halogen acid. Say for instance, we take benzene diazonium chloride and treat it with copper powder in the corresponding this halogen acid, that is HCl. Again we get we get chlorobenzene plus HCl. Now this reaction, this is known as Guterman's reaction. Now this is simply a modification over this Sandmeyer's reaction, because in this case we use copper powder instead of cuprous chloride. Similarly, if we have to prepare this bromobenzene, in that case what we do, we benzene diazonium chloride, it is treated with copper powder, then using the corresponding halogen acid we get bromobenzene plus N2 plus HCl. Now as far as this iodobenzene is concerned, iodobenzene can be this can be obtained by treating benzene diazonium chloride with aqueous solution of potassium iodide. Now aqueous potassium iodide, it reacts with benzene diazonium chloride to form iodobenzene N2 and this nitrogen plus KCl. Now we have got another method which is used for the synthesis of this chlorobenzene. That means we can this chlorobenzene, this can be obtained on a large scale by passing vapors of benzene over by passing the vapors of benzene, HCl and oxygen over heated copper chloride, that is used as a catalyst to form this chlorobenzene. This that is called as, that is Rossig's method. So that is used for the commercial synthesis of this chlorobenzene. So these are the few methods for the synthesis of these haloarenes. Then comes the chemical properties. Then comes the properties which include physical and chemical, that we discuss in the next lecture. Thank you very much.